The reason is for this machine. It's brand new. It's almost $1 million US.
Quali sono i segreti della produzione di un Macintosh?
We tell all the dealers the reason for the output transformer is so the customer gets all the power that they paid for. You're going to get 600 watts in the 8, 600 in the 4, 600 in the 2.
Esperienza, passione, artigianalità. Sono queste le prime 3 parole che incontriamo sul sito del più noto marchio di amplificatori della storia dell'hi-fi. Quando abbiamo ricevuto l'invito per poter visitare l'azienda, non potevamo crederci. Dopo più di 20 anni nel promuovere, sponsorizzare ed ovviamente vendere gli amplificatori più famosi della storia,
ciao a tutti, sono sempre io Davide di Audio Costruzioni.
siamo quindi saltati sull'aereo in direzione Binghamton. È un sogno che diventa realtà. Siamo stati invitati dalla più iconica e famosa marca di hi-fi di tutto il mondo, la Macintosh, qui a Binghamton nella loro fabbrica per vedere come sono prodotti con i nostri occhi i loro fantastici amplificatori. Siamo alla Macintosh a Binghamton. Fondata nel 1949, la fabbrica situata al 2 Chambers Street di Binghamton, New York, è stata costruita nel 1956.
So you can see how many times the building is add on.
E da allora l'azienda è sempre rimasta nella stessa sede. Nella metà degli anni 2000 è stata aggiunta una nuova ala alla parte anteriore della fabbrica, contenente l'ingresso principale, la sala formazione, la sala ascolto e gli uffici. L'azienda conta ad oggi circa 170 dipendenti ed il talento di ogni singolo è dedicato a disegnare e costruire i migliori prodotti audio al mondo. L'esterno della fabbrica, come potete vedere, ricorda un amplificatore Macintosh. Pensate che in questo tour abbiamo avuto la fortuna di essere accompagnati da Charlie Randall in persona, presidente Macintosh dal 2001.
So production is set up in like a big U. Okay, we're actually standing right here in the bottom of the U. Pretty much down this side of the factory are what we call sub-assemblies. So everything that has to go together before we put the final unit together. This happens to be one of the last sub-assemblies. This is printed circuit board area. So the raw boards come over here, and the first thing they do is they go on these machines. This is the SMT line. This is the meter light board for like 2 kW or 2.1 kW or 1.25 K. This is actually the silk screen. See the pattern? So the pattern matches this board. And this stuff, it's the consistency of like toothpaste, is actually the solder. So what happens is the silk screen goes on here, the board underneath, push through. So every place we want to put a part, it's got a dab of solder. Okay? And the solder is sticky enough to basically hold the part in place until it goes into the oven.
Come ci si può aspettare, l'azienda è divisa in vari compartimenti. Siamo nella zona produttiva, quella che loro chiamano sub-assembly, quindi dove tutte le parti grezze vengono assemblate. La cosa particolare che mi ha stupito di Macintosh è che, nonostante sia un'azienda con dei volumi importanti, abbia sotto un unico tetto sia la parte produttiva che la parte di ricerca e di sviluppo, ma anche la parte di management, e tutto viene prodotto con una grandissima artigianalità, ovviamente coadiuvato dall'utilizzo di macchinari sofisticati. Nonostante l'hi-fi sia una passione da uomini, lo sappiamo bene, pensate che più del 70% degli impiegati sono invece donne.
There's 2 machines. These 2 are identical. The only thing that makes them different is the parts that are loaded on it and the programming, obviously. What you see here, there's the same amount of banks on the other side. So 2 times this amount of components on each machine. This is one component, the little black spot right there. And when you think about how fast, the machine puts on 18,000 parts per hour. Every time that spins around, it picks up 30 components. Goes over top of the board, puts the 30 components down, picks up 30 more, puts them over top of the board, puts them down. You see the light flashing?
Right.
That is taking a picture of every component, okay? If something happens where the orientation of the component is wrong, the machine is smart enough to flip it and put it in that quick. If it's the wrong part, it'll flick it into the bin, it'll pick it apart again. If it's wrong again, then the machine stops, the light goes off, which usually means they loaded the wrong part in the wrong hole, right? Or the manufacturer gave us the wrong part. So between the 2 machines, 36,000 parts per hour. This department builds about anywhere between 10 to 15,000 boards per month. So because of the high current parts, like the power amplifiers, you can't get a big enough part to handle the power, so we still have to use the through-hole type. That is surface mount, where the part sits on top of the board. This is what's called through-hole, so the part gets bent, goes through the board, and then affixed that way. So basically it just put on all these resistors. These parts have been put on by the other machine, SMT. This machine puts on about 7,000 parts an hour. This machine, because see how the part is shaped? That we call axial. So this is the axial machine. Looks like an axle. Okay. This one is a radial, and it puts on like these capacitors, transistors, that, you know, three-legged devices, that type of stuff. There's some components that you can't put on by the machine. Physically, they're too big, like this, or they're it's like tuner, for instance. We only have one tuner, other than what you can put into the integrated. So it doesn't make a lot of sense to take up, because they're special parts. We would have to take up so many carriages. So we do a lot of those parts by hand. And then this is the terminal board for 9500. So the color codes match their bin. So all they have to do is look at the drawing and pick and put. This type of tape that you see, this is actually made out of Kapton. Kapton is very high heat, because we don't want solder on those, because that's where the binding post mounts for the speaker connection.
La prima parte è dedicata all'assemblaggio delle schede. Come abbiamo visto, alcuni dei componenti vengono posizionati e saldati attraverso la linea SMT, altri invece vengono semplicemente posizionati attraverso la Axiom Machine e la Radio Machine, ma devono essere ancora saldati.
So after, obviously, the first line of machines, those parts are soldered, the SMT. The parts that are put on by the axial machine and the radial machine and by hand, they are not soldered. So this is a wave solder. So now you can see everything that's not soldered, it'll go on here. These rails move in and out depending on the size of the board. The first thing that happens is flux is sprayed on the back of the board. Flux is the activator for the solder. Then it goes across the preheat. When the board gets up here, the wave will turn on. It'll be like a waterfall, and the board is set up to just skim the top of the wave. If the board is set too low, solder comes over, because it's sitting at about 500 degrees F. It will catch the parts on fire, because the parts are basically plastic. So too low, not a good solder connection. Too high, fire. So it's got to be just right, and the board is only that thick, so the precision is pretty good. So depending on each board, because each board has different mass to it, different width, you have to change the speed, you know, that the board goes up across, and then they also have special apparatuses that like go on the front of the board to push the solder out of the way, because the big boards can actually bow like this, right? So after the boards come out of here, there's still components that have to be put on the board, and these are what we call non-wets, which really means we don't want flux sprayed on them, or they can't stand the temperature, or they're just too big to fit in the machine, or they're on the back side of the board. So sometimes we have components on this side and sometimes on this side. Perfect example, preamplifier. It's got the display and the controls. Most of the semiconductors are facing inside the unit, but the display and the controls are facing out. Obviously, you can't put them controls down into this solder, right? So like this, right? That's the display, and it goes on the back side of the board.
Ecco, come possiamo notare, alcune delle saldature possono essere effettuate automaticamente, sia attraverso l'SMT line, sia attraverso questo macchinario a cascata che abbiamo visto, ma altre devono ancora essere effettuate attraverso un operatore fisico, perché delle schede hanno magari due facce e quindi non possono essere inserite in nessun tipo di macchinario. Come in questo caso vediamo una signora che sta saldando per l'appunto delle componentistiche.
So all of these boxes, if you notice, they have a model number, right? So it's for a specific printed circuit board. So like this is a power supply board for the MC255, 257, PS2K meter logo. That's actually the board that he was building over there. And these boxes we make internally, and they have pins that touch different parts of the board that we want to test. So what we're testing here is just functionality. Nothing to do with audio performance or anything like that, just making sure the board functions before we actually mount it in the unit. Each of these boxes, they interface with a computer in another box, and for him it's pass or fail. So once he starts the test, he doesn't even have to watch it. The only thing he has to see is if it fails, the test stops. He'll tag the board, go on to the next one, and when he's all done, like right now he's doing a repair, and it's probably a missed solder connection, or sometimes a bridge, solder bridge, that type of stuff. But the failure rate's only like 1.5%. Sometimes, most of it, the failure is going to be from the hand assembly, human error. They forgot a part, or they switched two parts, that type of thing.
Sinonimo di grande qualità e di grande attenzione è il fatto che tutte le schede vengono manualmente ad una controllate attraverso questi box specifici in azienda, dove ogni box è preposto al controllo e a effettuare una serie di test sulle schede. Charlie ci diceva che meno dell'1,5% delle schede risulta poi avere un problema, e spesso è per un errore umano. Magari qualcuno si sbaglia a mettere un componente, ma poi c'è un addetto preposto, come vediamo in queste immagini, che sistema il problema.
If you've never seen MX123, that's how we build. That's basically all the boards that go into the rear panel. So all built up, rear panel goes on. So what we do is out back, you'll see it, but there's a group of people doing what we call sub-assemblies. So they're basically putting this together, and it comes out here as one assembly so that the final assembly people can just drop it into the unit. Because these are the people that are screwing the unit together, okay? So, and what happens is, like, this bench is set up for, is that 462? Sure. So MC462. So he takes the chassis over there on the table that goes up and down. That's where he'll put the heat sinks, all the output transformers, the power transformers, any circuit boards. Sometimes they usually build a team of one, or sometimes team of two. Before we started doing the sub-assemblies out back, there would be 2 or 3 people sitting at one bench. But this is, during COVID, we had such a huge backlog that we had to do something to increase the production. And this area used to be very tight. This has just got relayed out about 1.5 years ago. So final assembly basically stopped at the pillar beyond the flag hanging. That was the end of final assembly. Now final assembly goes all the way to the warehouse. So what he's doing probably like mounting the transformers and the heat sinks, then passes it up the conveyor to her, and then she does all the wiring just to speed it up. 611, Chinese version.
Yeah.
He's on America's Most Wanted, so he wears the mask. So if you notice, like the power amplifiers, we can leave the front panel off so we don't scratch it.
Okay.
Unfortunately, like on the home theater stuff and preamplifiers, integrateds, we have to put the panel on because there's so many controls on it, right? But here, same thing. The test is automated for the most part, and we're checking frequency response, distortion, channel separation, power output level, everything. On the amplifiers, the last thing we do is we apply a short circuit when the amplifier is running at full power for 30 seconds, because we have protection circuitry called Sentry Monitor inside, and one, we need to test it, and two, what that does is throttles back the amplifier so that it can sit there and all the parts can operate in a safe operating area forever.
Okay.
The worst thing that's going to happen if you don't remove the short circuit, eventually the amplifier will overheat and shut down, but there's other circuitry to protect that. Then it'll cool down, restart, and it'll try to drive that short for the rest of its life. It doesn't care. So once the units get to here, this is what we call pre-pack. Okay. So it's right before the units go into a box. They're all tested. The only thing that he's doing is basically putting on the rest of the cosmetics, the front panel, the top covers, but we also adjust the blue meter here. So if you notice the screen up top, that is hooked to a colorimeter, and we put the colorimeter in front of the meter. See how they're not quite balanced? The right one is darker than the left one, okay? He will put the suction cup on the front and adjust the blue and green LED for the right intensity. So once the units get to here, they're physically done. The last step, the guy that works at the bench here, he actually works for QA. So he's inspecting cosmetically, also lighting, make sure all the hardware's in place, and also audible test for like pops, clicks. And then the last thing he does is an installation integrity check to make sure the unit is safe. If it passes, and if it's over 50 kilo, it's packed on this side. If it's under 50 kilo, it's packed over there.
Okay.
Only because they have special lifting equipment
Right.
to rotate the amplifiers. How you doing, Frank?
Good. How you doing?
Good. They have lift tables that go up and down. They have a suction cup to pick the big units up. If you want to see what a PS2K looks like in the box, that's what the PS2K looks like. So, warehouse, both finished goods and raw material. Raw materials back there, finished goods here. When you think about C55 for you is 1 SKU, for me it's 9. Because of all the countries and different certifications. And so like this one, yours would be 2405. This one's 2404. This is going to the UK. Different line cord, okay? 61201, 120 is the voltage. 1 is USA. 240 volt for Europe, but this one's UK. Obviously speakers is only 1 SKU, right? Other than color. So you see the old amplifier up there? There's actually 2 of them. See the up here? That is MI 3500. That actually are MI 350s. It's 2 of the, I think 10 or 12 that powered Woodstock.
Woodstock, right?
That they were at Woodstock. Yeah.
Terminata la fase di assemblaggio, siamo quindi andati nel magazzino dove abbiamo potuto vedere tutti i Macintosh imballati e pronti. Ci diceva che oltre al fatto che se noi abbiamo un SKU, quindi un solo prodotto, lui ne ha 9 perché mercati differenti hanno regole differenti, quindi nomenclature diverse, e quindi di ognuno di questi prodotti, dei prodotti che vedete a catalogo Macintosh, per loro ce ne sono 9 differenti. Ci diceva Charlie inoltre che il loro magazzino è stoccato per 90 giorni, che è una cosa assolutamente inusuale, e questo fa capire intanto il volume e la velocità di rivendita che hanno di questi prodotti, ma anche la grande capacità che hanno nel progettare e costruire tutto in casa, ed anche molto velocemente, visto che praticamente tutti i processi sono fatti in casa Bigetton.
This edition we put on in 2 years ago now, and the reason is for this machine. It's brand new. It's almost $1 million US.
Wow.
So it's how we cut all of the sheet metal. This is the material, comes in with the paper on it. And then we do all the processing, even the bending, like that, with the paper on. And then first time we see the chassis is when we go to put the nomenclature, the screening. If it's got a scratch, one sheet, $750 US. And like this is 1.25K. I get 4, maybe 6 chassis out of a sheet. That's it. I throw away because of damage almost $250,000 a year. This machine is also brand new. The nice thing about this machine, like to form the chassis, you set up all the tools. These move automatically, the stop. So the operator can go bloop, 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 and when he's done, he's done. Where this machine set up, make one bend, put the part down, make another bend, and then tear down, set up again. It's crazy. This machine and this machine, basically the same, just 2 different manufacturers.
Quando ci domandiamo perché un Macintosh costa così tanto, beh, oltre ad avere un'azienda negli Stati Uniti non delocalizzata dove magari la manodopera costa meno, Charlie ci faceva vedere qualche componentistica che ha dei prezzi importanti, perché pensate che ognuno di questi fogli metallici costa $750 e da ognuno di essi ne vengono ricavati 4 chassis, quindi più o meno $200 a chassis, solamente di costo di puro prodotto.
So after the sheet metal comes out of the shop, it gets painted, but after painting, it has to have all of its fasteners put in. So to hold the feet, to hold the printed circuit boards, hold the meters. So this is the painting. It's a continuous conveyor. So if you were to hang your hat here, 25 minutes it'll come out. But the way it works is first the parts go through a wash system because the sheet metal has oil on it. And the wash is to remove the oil, but also it uses acid to etch the metal. So like a very light sanding, but it's all done by acid. Into the oven to dry, out of the oven to powder coat, back into the oven to bake the powder coat, then through the cool down chamber, and then it comes out here. We can go inside. These have just been sprayed. Now heading to the oven. That big box in the back is all oven. In and out of the oven, through the cool down, and back out. So loudspeaker production is out here, obviously ML1, but also remember I told you the sub-assemblies for final assembly, that's all done by these people. So like you can see the sub panel for one of the preamplifiers are integrated with all the controls sticking up. And then on this side is basically amplifiers that don't fit the normal production. So like the amplifier for the PS2K, also MC901 is built over here. This is service department. You can look around, there's always old product. You can see the 4280 receiver, old CD player, really old CD player. I think that might be one of the first ones, 7005 or 7009. There's an old amplifier. So typically out of warranty, meaning the customer's had it for 20, 30 years. That's for the end customer. Sometimes they take it to the dealer and then dealer sends it to us. But lots of times the customer drives it up or sends it up themselves.
Can do even only for US, for end customer?
We only do US and Canada.
US and Canada?
Yeah. But we also have authorized service agencies throughout the US. There's, I think, around 30 of them. So the customer, but when it's a really old collector's piece, they would bring it back here.
Sure.
See the wheels? The front door, the cover here, is actually a ramp. And you pull it out.
Right.
Okay.
It's Marv.
If not, you can't handle it. Can you wind something or no? Yeah. So this is where we wind all the output transformers. We do 3 types of transformers. One for the vacuum tube amplifiers, because all vacuum tubes can't drive low impedance, so you need the match of the transformer to match the 8 ohms. That's what she's winding now, MC275 output transformer. In the case of the solid state amplifiers like integrated and MC152 and MC312, those are what we call a single-ended design, because if you look at the back panel of the unit, you have common 2, 4, and 8. In the case of the fully balanced amplifiers, 462, 611, 1.25K, you have 2 ohm minus, 2 ohm plus, 4 ohm minus, 4 ohm plus, because those amplifiers are balanced from input to output. So you need to keep that separate. You can't use a single-ended design because like the 611 is a 300 watt negative going amplifier and a 300 watt positive going, and we drive the top and bottom of the transformer.
Yeah.
And that's what allows us to get like signal to noise ratios on those that are 135 dB. You know, it's crazy. Each of the slots are numbered, and then depending on the tap meaning 2 ohm, 4 ohm, 8 ohm, determines how many turns we put on the transformer. The nice thing about the transformer, as long as you put 2 ohms on the 2 ohm tap, 4 ohms on 4 ohm tap, 8 ohms on the 8 ohm tap, my amplifier is always going to see the same impedance all the time.
Right.
So it's never going to overheat. So if you take an 8 ohm amplifier with no transformer and you put a 4 ohm load on it, you're asking for twice the current, which means twice the heat, right? Which means it's probably either going to shut down or it's going to fail prematurely just because it's trying to drive more than what it can be rated for. So in the US, when we do the dealer trainings, we tell all the dealers the reason for the output transformer is so the customer gets all the power that they paid for. Because you're going to get 600 watts in the 8, 600 in the 4, 600 in the 2. The colors, not for the spirit of Christmas, because when they're done, when Kaoko's done, it looks like a bunch of wires hanging out of every tap, and the ladies over here, they have to connect the wires that go to the speaker terminals, to the drive, to the amplifier. This is the transformer that she's wiring right now. Obviously, it doesn't have the core material yet, and it doesn't have the lead set. So some of these wires go to 2 ohm, some go to 4 ohm, some go to 8 ohm, and drive, feedback, and then common. So That's what Kim's doing now. Right now it's just a coil, so before it becomes a transformer, you have to put the core material in. Core material is M6 carbon steel, and it's grain oriented. If the grain is going the wrong way, it won't work. If it's not M6 material, the transformer will saturate and we won't get 20 hertz distortion, for instance, because it starts to look like a short to the amplifier. We use two types of core material. This one, complicated. It's called the EI, okay? It's an EI core. The other type we use is this one, 1.25K, 2.1 kW. It's a C core. So it's actually still laminated steel, wound like a donut, and then cut by a laser and sent to us in the matched halves. If I was to try to make this transformer with that core material, it would have to be about that long. Just from sheer weight. Because if you feel this, it's probably about 17 kilo. This one's about maybe 5 kilo. So just 3 times the size, right, to match that. They have to be put into the can. You know, when you look at an integrated, you see 1, 2, 3. Those are what we call the cans. The can goes under here, and we actually pour the tar out. Okay, the tar is sitting at 450 degrees F, and the reason why we use tar, when it hardens, it still is soft, and the tar suspends the transformer in the can. So both magnetic resonance or mechanical resonance doesn't happen because the tar absorbs it, but it also helps to seal the laminations of the transformer. So the tar is 450 degrees F. It's hot. It's the most photographed process and the most simplest. You know. Now it takes about 25-30 minutes to cool before you can handle it, even in production. So here's where we put all the nomenclature. So you can see the offset press silk screen. Depending on the unit, like 275, 4 times across the machine, because 4 surfaces to screen. High pressure water jet, it uses air, water, and a substance that looks like sand. Yeah. That is actually garnet, and garnet is a gemstone. Some guys, mostly men, wear it as a tiger eye. So the natural form is like this. We get it like this. Yeah. So what happens is the machine, any place we want to make a hole in the glass, we pierce at 10,000 PSI. After it's done piercing all the holes, it will ramp up to 50,000 PSI, come back, find that hole, and cut any shape we want. So after the glass panels are cut, they have to be screened. So up until 4 years ago, we used to do everything the same way as the sheet metal. A little bit more automated than what that was, but still we couldn't keep up with the volume. So we had to do something to ramp up production. The fortunate thing, we were only 1 hour from Corning Glass. And Corning Glass is the glass gurus of the world, right? Gorilla Glass, okay? They were working on a special glass called Willow, and Willow is glass that you can actually roll up. So like for kitchen backsplash, inside of elevators, but they formulated ink to basically print on the back of the glass, working with this company. That's what we did. So this is the kind of resolution. So basically anything that we want to print on the glass, we can put on it, right? UV cured, so as the ink goes down, the head has a UV light inside it, so immediately it's dry. So it's not one pass of black, one pass, it's doing all the passes at the same time. So the back, like this, right? A lot of work goes into the panel after it's even screened because of having to block all the light, and dust is a big problem. That's it.
Terminata la visita alla fabbrica dove vengono costruiti fisicamente gli amplificatori, era ormai ora di pranzo e ci hanno portato in una pizzeria, tra l'altro buonissima. Finito il pranzo, con Charlie, Cindy e anche Mark, che è il direttore marketing, con cui siamo riusciti anche a scambiare qualche chiacchiera su tutto ciò che riguarda il marketing dell'azienda, ed è stato davvero molto interessante. Ci hanno portato a far tappa da Audio Classic. Audio Classic è un negozio storico a Binghamton ed è uno dei migliori venditori di Macintosh di tutto il mondo. Si dice che abbia anche un filo diretto con con l'azienda e nel loro negozio, oltre ad avere un tripudio di tutti i Macintosh che uno può desiderare, hanno una sezione di collezione dove sono custoditi sia i primi modelli ma anche dei prototipi che non hanno mai raggiunto il commercio. Terminata la breve visita, siamo tornati in azienda perché mancava ancora tutta una parte, quella di ricerca e sviluppo.
So back in here is mostly some electrical engineering, but mechanical, like Zach, the guy we just walked by. And then we have RF chamber. So this is basically for checking radiation from the product. MC 2.1 kW with no clothes. Pete's the designer for 2.1 kW. And this is the bad boy room. Anybody that gives us trouble. Basically, it's an anechoic chamber, right? So one thing we use it for, you put a speaker in here and you see the markings, the radius. You can measure the off-axis response. So how much sound disperses, out of the front of the cabinet. And then we also use this room for like mechanical noise. Could be how quiet's the CD mechanism, or if the product has a fan. And if we think it's too noisy, then we try different tests to try to lower the fan noise or the vibration. And if you clap your hands, there's no echo, right? So this room is obviously used by the engineers, so constantly product in and out of here and simulate in a living room, right? Yes. That's why furniture and curtains and that's it.
L'ultima area dell'azienda che abbiamo visitato è stato il teatro, una zona dove è installato tutto il meglio che Macintosh può offrire. Come frontali sono utilizzati due XRT 2.1K, listino italiano 200.000 euro, amplificati dai nuovi finali monoblocco da 2 kW ciascuno. Pensate che solo per la parte posteriore dell'impianto sono stati impiegati ben 6 finali da 1200 watt cada uno. Perché hanno utilizzato tutta questa potenza per l'amplificazione? Because we can. E giustamente, se non lo fanno loro, ma chi lo deve fare? La demo è stato qualcosa di incredibile. Quello che ci ha stupito maggiormente durante la visita di questa azienda è sicuramente l'altissimo grado di artigianalità ancora oggi impiegato e l'umanità delle persone che animano questa azienda. Sotto la stessa struttura, come abbiamo detto ad inizio video, troviamo la zona produttiva, il reparto di ricerca e di sviluppo e management. Torniamo con la consapevolezza in un mondo dove ormai quasi tutte le produzioni vengono dislocate in paesi con manodopera a minor costo, di proporre alla nostra clientela prodotti fieramente made in USA, dove il talento di ogni singola persona è impiegato al costruire il miglior prodotto audio possibile. Il modo in cui ci hanno accolto, la disponibilità delle persone, la grande qualità dei processi produttivi e dei materiali utilizzati non può che darci la conferma che Macintosh è, dopo 70 anni di storia, ancora all'apice della produzione hi-fi. Ma poi dove lo trovate un presidente che ci invita ad una grigliata a casa sua e a fine cena si lascia intervistare? Ma questo lo vedremo in un altro video.